Hi there guys, welcome to day, I think it's 14 of Coding Every Day. Today we're going to be doing Leetcode number 50, POW XN. This is a medium, so basically we're supposed to implement the power function, which raises x to the power of n. Okay. This doesn't seem like too tricky, but I feel like there's a bunch of different cases. X is not 0, n is 0. So yeah, either, if we look at this, n is an integer, yeah, and it's either negative or positive, and we'll do, guess it depends, depending on that, but we'll do an if statement, right? So we'll say, if n is bigger than 0, and elif n less than 0. Right? If it's equal to 0, it won't be ever equal to 0, but we'll keep it there for now. So if n is bigger than 0, what we want to do is we want to do while for I in let's think about this, right? If I go 2 to 3, if I was like 2 exponent 3, right? I would multiply it by something 3 times. From 1 to n, x equals x times for how many times it is, right? Yeah, and then if it's less than 0, for I in range 1 to n, x, boom, boom, x. Is it not this simple? This would be crazy if it was this simple. Absolutely not. Okay, guys. So, oh, okay. So I'm understanding. Yeah, this is definitely not the right answer. Yeah, this one. I just gave it 2 as well. Oh. Okay. So we'll have to fix up both things. Made a little dumb mistakes, but it's fine. So for I in range 1 to n, so we need initial. So if n is bigger than 0, we'll say start input. No, not inputs. Start first equals x times first, right? So this one will work for 1024. The other ones won't work, but this one will work for 1024. Yeah, these ones work for 1024. Perfect. And then I have to do the negative ones. So if it's less than 0, okay, the way the negative works is if I have 2 exponent negative 2, I do 1 over 2 exponent 2. So I just do it normally. So what I'm going to do is I'm going to go x in 0. Then I'm going to say n equals n times negative 1. Right? And then we do for I in range 1 to n, because it would just, like, it's not doing anything here. Right? What's going into this, because it's a negative number. From 1 to n, we have boom, and then we're gonna go here, and we're gonna go, so first equals x as well, same thing as this one, and then at the end we're gonna go x equals 1 divided by x, and then we return that. And I think this should work. No. Okay, well, let's think about it, right? Because it's 1 over 2 divided by 2, right? So, for example, right? 2 exponent negative 2 is 1 over 2 exponent 2. So if I do n, if n is less than equal to 0, less than 0, n equals n times negative 1, right? Or absolute n, right? To get positive. First is equal to x as well, right? This is just a random x there. And then we have for I in range 1 to n, x times equals first. I think I put a capital here. That might be the reason. And then we 1 divided by x. Yeah, okay. I'm expecting some special cases to pop up. Yeah, okay. Ooh, n is equal to 0. So, n is equal to 0. There's that case. Else. Oh. We'll just test this as a special case. Just so I don't waste another submission. I got most of the test cases passed. Yeah, submit. I think they should work then. That's like kind of the only cases. Memory limit exceeded. Oh, wow. What the hell? Memory limit exceeded. I didn't even know this was possible. Wow, okay. That's not good. This is for this too, for I in range times equals first. I'm confused, like I'm not using that much memory. Or I don't think I'm using that much memory. Like I'm using like this x is 0.01. Then n is that. So I'm doing first equals x. Exceeded. I need to go read back this, man. Okay. So the problem here so basically there has to be a better way to do exponents. That's what you're telling me. Because let's look at like, I don't know, let's go math away. So I can do this for me. Four zeros. No. Okay, we're gonna have a clause. Let's see if it gets under, because we own. Okay, we're gonna have a clause. Basically, we're given stuff that only results in 5 integers, right? So 1, 2, 3, 4, 5. So we're gonna go here and we're gonna say, oh, we'll have an if statement here. If x is less than 0.00001, return 0, and then we'll add this to here as well. Add this to. Here's well, if I run this should work with that one thing, right? That's how I'm supposed to be returning 0. Memory limit exceeded. Should put it here, and my bad. Let's see, how would I even get 0.0001, right? Let's go math over. So if I'm trying to get 0.001, 1 over x has to equal 0.001. Solve x. X is that. That's fine, I copied it. So we're gonna go here. And we'll go if x is bigger than 10 million, return 0. Right? Because that means that when I do 1 over x, it will grant me an error. Right? The memory limit exceeded as well. What the fuck? I have no idea. Like, I'm trying to catch it so, you know, it doesn't go over the decimal limit, but it's just saying memory limit exceeded as well. It's not like, not even time limit, just memory limit. What does memory limit mean? Like, okay. So defining too many variables, that seems to be the issue, right? Zigzag conversion. So it seems, yeah, the issue seems to be defining too many variables. It doesn't want me to use first. Maybe that's the problem. Ooh. Oh. To use X and N. Like hypothetically, guys, let's hit a bit of a copy. I'm not saying that this is the solution, but if I just do like this shit, this is an exponent thing, right? Exponent rules. Exponent symbol Python. I think it's just the like shift 6 double asterisk. Okay, so if I just do does this work, or is it telling us not to use this function? Yeah, I feel like it's 100% telling us not to use this function. So I won't, because, like, I feel so cheating. You know what I'm saying? Like, there's no way. It's asking you to, like, do it legit. But I think the memory limit exceeded is it's telling us we're using too many variables. So we can kind of like ignore a bunch of things. We could just do, so hold on, let me change up the code real quick. So I'll keep this. I'll just say, so if n is less than 0, hold on, if n equals 0, return 1. If n is less than 0, n equals abs n. Not even, I'm just gonna decrease this, and then I'm gonna put absolute value of n right here, and then if like, this won't work for this one test case. Can I do it? I don't want to do this test case, but I have to somehow find a way to remove the variable first, right? So let's think about it, right? X is a float. It's weird, you know what I'm saying? Like, if I let's copy this. Let's not copy this over, because this will work. If I delete this test case right here, how do I delete the test case? This is gonna work for 1, 2, 3. Yeah, but it's just, it doesn't work for 4 because memory limit exceeded because I'm using too many variables, right? So to do this, I need to try and remove the only variable that I have, which is first. Is there a way to make it, okay, like, how do I, like, the only solution I can think of is doing x to the star of x exponent negative I. And this is gonna work. But then I'm using the whole function that I'm not supposed to be using. Oh, it didn't even work. Cool. Okay, so I actually lied. Didn't even know that would work. What if we, let's try that. I want to try that submission again. I just want to get the test case back because I don't want to remove it. Yeah, memory limit exceeded, use test case. Okay, cool. So, yeah, we're allocating too much memory. So it's, oh, I got a black and dead on the bread. It's like, this is it's just something I don't know how to do, I can't lie. first equals x. If I do 3 exponent 3. What if I just do like if n bigger than 10,000 return like that? That won't work, right? If n bigger than right, surely this wouldn't work. Yeah, okay. That's a pretty dumb solution. I think we might have to. Ooh. Basic math. I think what we're gonna do is we're gonna. It's all C++. Wow. Yeah, this guy's a genius right there. It's gonna do, yeah, math.py. It's just gonna be, wow, can you please upload please? Yeah, what a weirdo. Oh, what if I use logs? This is actually a genius move. This is actually a genius move. Hold up. This might be it. If not, I'll look up a solution. But hypothetically, right? If I do, let's open up Mathway again. It's my online calculator. Go to. So if I want to do, right, 3 exponent 2, right? And I only have 3. I'm gonna do 3 exponent. I'm looking for in the range, right? So I'm gonna do 3 exponent 3. We'll lose 3 exponent 4. But if I log, log 3. What's log 3? No, log base. No. There's something with this. I don't know what it is, but there's something with this. If I have, yeah, log. So if I do, like I'm doing 3 exponent 4. Okay, so I can do 3 exponent 3 exponent 3 exponent 3 exponent 3, right? And this is gonna give me like my whatever 81. And instead of that, I'm gonna do 3 exponent. Well, okay, well, you have to do it with 2 at once. So to get 3 exponent 3, if I do log in Python math.log natural log of different numbers x and then base. Ooh. So I can run here and I can run math.log how base, right? X in the base. And then obviously the way log works is it says, okay, that's the exponent. The exponent, that's the, like we get the exponent from that. No, let's give. Alright, sorry about that, guys. Just had to go deal with something real quick. But I still do think that there is a solution with this. Alright, so for example, right, go back to math, we have 9. Right, if we want to get 3, 9 log base what with what? We know we have to use 9 in there. Log base 3 of 9. That's by 2. Guys, 3 exponent 2. What if I do times? I think there has to be something. If I have, okay, we're given, its base times the exponent gives you this. I really don't want to do with the. There has to be a solution. Like there has to be a solution, so I can get rid of this first variable. Log base 3n. Because this is x and this is n. Right? If I do 4. No. Log n. Look at the equation, right? We got exponent, or like what? We have x to the n equals val, and then we have log base x to the val equals n. So if we're going one by one and we're adding to each one, right? X to, or if I'm using 3, right? 3 to the 1 equals 3, right? Log base 3 to the 3 equals 1. I don't know why I put 3 here, but ignore that. But I need a way to make it so this equals 1, but I need to find this number. No, I have that number. Okay, let's try with a different number, because like, so 3 exponent 2 equals 9. Log 3 of 9 equals 2. So I need to use how to find the base of the log with the rest. -4. 81 equals b to the -4. Yeah, this is stuff you can do on calculator, but it's like, I don't know if you do this in person. But I have to do this calculation and shove it right here. No matter what my number is, right? My number's gonna be 27. Because I have my 27, and because I have what exponent I'm in, which is I can use that. So log Like right now we have we want to do log base x, no, log base what we want x equals I. So now we have to do this whole ordeal of things. We just gotta cube root it, or root it by whatever it is. So let's look at the math.root function. Math.root Python. I don't want square root, I want square root. Cube root in Python. Alright, we're gonna look up a solution because like while I don't know how to do the square root things, so I can't really find that. Like I can't. 3 exponent of y equals 27. Or something exponent 3 equals 27. To find that something, you need to cube root it. There's no like program to find it. So we're gonna look up pow x and Leetcode videos.
Hey everyone, welcome.
What? If x equals 0, return 0. If n equals 0, return 1. Res equals helper.
Negative n, or if it's a negative value, is just equal to 1 divided by. We're not going to calculate negative numbers. We're going to calculate every proper so that we don't ever function rest in a negative exponent. So I'm just going to take absolute value, return the result, and get the result of whatever it was, right? But now, before we actually return the result, what if n was negative? Well, first of all, if n was positive, we can just go ahead and return the result, right? So if n is otherwise, if it's negative 0, then we're going to go ahead and return the result. Otherwise, if it's negative, if the exponent was negative, then we want to say 1 divided by the result, right? That's the main, just a couple, no matter what. So it's going to see helper, and we're going to pass in x. X is always going to stay the same, but remember the n, the exponent is going to be divided by 2. So integer division, right? So you're probably thinking, okay, if we had n is 4, right? If we divide it by 2, n is going to end up equaling 2 in this case, right? So we have to handle that because remember, we have to power of 2 of 5, right? Because the value might as well and multiply. Just exponent was odd. How do we know if the exponent was odd? Well, we can say if n modded by 2 is non-zero. So if this is the case, we can return x times the result. If it's not the case, that means x to the power of 2 is going to be equal to x to the power of 5, right? Because the helper is what's going to calculate x to the power of 2, and then we're going to multiply these two. We're going to multiply the value by itself, and then we're going to have one more x at the end. Let me show you without actually, I might as well show you what we're talking about. So we're going to get the result from our helper. We're going to take result and multiply it by itself, and then before we return the result, we're going to say, don't just return the result, return x multiplied by the result if the exponent was odd. How do we know if the exponent was odd? Well, we can say if n modded by 2 is non-zero. So if this is the case, we can return x times the result. If it's not the case, that means we had an even exponent. That means we can just directly return the result, right? We took the result of this, right, and then we multiplied it by itself, and then we can return that, right? That's the entire problem. That's all the logic. Let's submit it, make sure that it works. And as you can see on the left, yeah, it's pretty efficient. It's about as efficient as you can get. There's one little trick I guess I'll show you. Probably most people won't care about it, but you can get rid of this line. If you remember from algebra, you know how exponent multiplication works and stuff like that. Instead of passing an x here, we can actually pass x multiplied by x, and then we won't need that line of code that I had below. So this will basically return, x to the power of n divided by 2 multiplied by itself. The wording.
Okay, so I didn't even know it was downvoted. Okay. So basically, yeah, apparently we're just gonna. This guy's code right here. Is there a easier solution over here? Python. Yeah, like no does gonna work. Yeah, but okay, honestly, if you're using, why are you doing this question with the PAL function? Yeah, this is so crazy. Everyone's trying this. Oh, okay. This is an actual solution. Alright, we're gonna copy up guy over here. Unfortunately, not really unfortunately, just that's just kind of what has to happen. Now that we've copied the code, what we're gonna do is let's try to understand it a little bit. Might as well. So helper is let's try to understand. So helper and x absolute value n, right? So this I understand, right? You're sending this helper to go do the function. So after, you're sending in x and you're sending in n, right? This is only gonna like take one time, I guess, to start. So that's if that happens. So, but then you're gonna say res equals helper x times x, and then n double dash divided by 2. And then we multiply again by res of n mod 2 is 1. Else we just return res. Just sending it back in to do the exponent, because then you do x times x and divided by 2. And you just keep xing until it becomes that, and then you multiply it again. If it's because if it's mod 1, if you divide it by 2, if you double dash divided by 2, you're missing an extra 1, because it's gonna go from 5 to 2. You're missing the you're missing the whole integer. Like, you're doing it one time to go from, or like 2 times to go from 5 to 3, but then you're skipping the 1, so that's why. Okay, so it makes sense why this code. To be honest, I really would have liked my thing to work. I really would have liked not have memory exceeded, but I mean that's an L we take today, and we do better tomorrow.